Hello everyone, so we are going to talk about the three different ways that we can write equations for linear functions, okay? So I first want you to start off by copying what you see right here, including the objective, the graph, and the question. So you can go ahead and pause the video to copy all of these. Make sure your graph is to scale and you're using your grid lines on your notebook to create your graph. When you are done, I want you to answer this highlighted question right here. What kind of a scenario is this graph representing? What kind of a scenario is this graph representing? Could you come up with a story that is being shown here, or do you see the relationship? Describe that. So what does the graph represent? Now we're going to move on and talk about the three representations. So you are going to create this graphic organizer that you see right here, all right, at the bottom of your notebook. And you're going to leave a little bit of space right here because we're going to do some work there, okay? So there are four different representations. We have slope-intercept form, and we call it slope-intercept because when you look at the equation right here, when you look at the equation right there, the slope and the initial value, the y-intercept, are both really clearly visible. The slope and the y-intercept are really clearly visible. So if we had a scenario or a word problem that said something like Ashley has $15,000 saved and she makes $5,000 every month, the slope there is what she's making every month, which is $5,000. And the y-intercept there is what she starts off with, her initial value, and that is 15,000. And both of those values are really clearly visible in our equation. The second form, is called point slope. And the reason we say that is because a point on the graph is clearly visible and the slope is visible. So for example, if we had an equation, a scenario that said Ashley makes $5,000 every month, we already know, we see that word every month, that's the slope. That's the slope. So we can see the slope very clearly in our equation, this $5,000. And after 3 months, she had $30,000. After 3 months, she had $30,000. Let me go back to my graph real quick. At 3 months, Ashley makes $30,000. That is a point right there that exists on the graph. That's a point that exists on the graph. So when I look at my equation, the point 3 and 30,000 is something that I can clearly see in my equation. I can see that point directly in my equation. So that's what I mean by that x1, y1 value. It's the x coordinate and a y coordinate of a point specifically on my graph. Okay? So I can see my slope clearly, I can see my y-intercept clearly. Now what I want you guys to do here is sometimes when I have point slope form, I can actually turn it back into slope-intercept form. Okay? And if you notice, the difference is in slope-intercept form, our y is alone on this side, but in point slope form, our y is not alone. So we are going to use what we know about literal equations. Think back to literal equations now. We're going to know what we know about literal equations to try to isolate the y so that we can turn this back in to this. So this is what I want you guys to do in this space right here. I want you to write the equation again. Okay. And then I want you to draw your line down the equal sign and get your y all alone. Get your y all alone and simplify this side. So if you have to distribute, and get your y all alone. I want to see what you come up with when you isolate your y. Does that last equation, when it's all simplified, look like this? I want to see your work. And then finally, the last form is called standard form, which is right here. And we are going to get to that later in this unit. Okay? So your goal is to have all of these notes complete. You should have some writing right here that describes the graph, and you should have some math work over here where you are isolating the y variable.